For our next example, let's look at another kind of evaluation we can create just using dynamo geometry as opposed to using some sort of external analysis tool. And we'll look at a whole class of different evaluations we create that are based on directness of panels and panel normals to either the sun or some sort of other object. Now we've done some looking at how you can take panel normals and compare how direct they are to the sun in some past examples. For this one, let's take a look at how we can compare the directness of the panel normal to some sort of object, some sort of view that we might want to take in. So it might be, for example, just something in the horizon that we'd like our building offices to be able to see. Okay, so the basic format is going to follow a very similar structure to what we did in the past example, and for all the examples in this module, where we start by just basically setting up the environment and creating the alternatives through step 3. In this step 4, we're going to define an evaluation or objective function by kind of creating some node logic for a single case, and then we'll encapsulate that node logic in a custom node. Then we'll basically integrate that new custom node, that function we've created, into the testing node, so we can evaluate it for each of the different test cases and report its values. So to give you a sense of what's going to be happening in this example, we have our basic tower kind of hanging around over here, and this might be the object of interest. For example, if we were in New York City and this was an office tower we're looking at, this object of interest could be something like, like a Statue of Liberty or an island or something that's kind of very interesting people value the view of. If it were a river or something else, we'd have a different type of geometry out there that we can kind of look at how well we can view it from the different office spaces. And our approach is going to be to basically take the surfaces of the building, divide it up into a series of panels, then just look at the normals to all those panels and kind of compare them to a vector that actually points to the object. Okay, so the basic logic is laid out over here. We again start with the original logic, and what we do in the example is just build a series of new nodes. Selecting some wall surfaces, panelizing those wall surfaces, computing some normals to those different panels, then creating a vector, and finally doing a dot product to compute a strength value. So that ought to look somewhat familiar to you. It's very similar to what we did when we were computing a directness to the sun. And when we go through and run that, you'll see that the type of values we get look very similar. Again, we're returning all the different data results with the inputs, the volume and the area, but we're also now getting some sort of a value which is giving us a directness score. In this case, all I'm doing is really adding up a bunch of scores for each of the different panels, and we can think about a lot of different ways we could construct that metric. But once we compute those directness values, how we aggregate them together into a composite value is really, there's some strategy behind that. We could use different approaches. So let's go ahead and take a look at how we can construct this example.